So, hello everyone, I am Harris, and today we're going to talk about TypeScript and multiple packages and how do we manage them. So, first of all, a little bit about myself. I'm a senior full stack developer in a company called Equals Group. We basically do travel money. I recently worked in a project where we created a travel currency wallet that has several different currencies that you can use while traveling. It has a physical card. Very interesting stuff I learned there. So I'm very passionate about traveling. I've been to 40 countries so far. There are more in the plans in the near future. The kind of guy that, my friends hate me for posting photos of places I've been recently. Generally, I come from a full stack background. I've worked a lot on both the front end and the back end with databases, with APIs. Microservices is something that we're going to talk about a bit today. A little bit of NoSQL is also something that quite interests me recently, now that I finally understood how to use it properly. And apart from that, scaling and infrastructure with Docker, with a little bit of Kubernetes, that's maybe for another talk. So, let's begin. Why TypeScript? That is the question. So basically, the whole purpose. We want to have someone that acts like a bodyguard, like this guy, that protects our code base from random data types that are untyped, so that we increase the quality of our services. Okay, now, on the serious note, how do we do it without any memes? And why TypeScript is going to help us? First of all, if we type our code, we automatically add much better quality on what we do. I don't know if I'm the only one where, while I was working with an untyped JavaScript framework, there was this bug that would occur in a very extreme edge case, where after a few hours of debugging, I ended up seeing that there was a very special case where a type becomes from string into a number, and then everything just gets destroyed. So with TypeScript, you don't have any stuff like that. Something I really like about typed code, especially with JavaScript, is that it acts like documentation. You can use, especially with a code editor, you can see every function or everything that you're using, what kind of arguments it expects, what kind of types it returns, and it helps you a lot without you having to navigate into the code like manually in order to understand what this code actually does. Again, that makes it very sweet in order to use it with the code editor. Something that I really like about TypeScript is that it makes autocomplete to actually work. I don't know how many times in React projects I struggle to make IntelliSense to work properly. With TypeScript, basically, as soon as you install it, everything works fine, like magic. Interfaces. We're going to talk a lot about interfaces today, and I will explain later why interfaces are going to be your best friend when it comes to TypeScript. Generally, TypeScript is designed to scale. What I mean by that? Because it acts like a guide on how you're going to write your code. That helps a lot with big teams so that everyone can follow the certain structure that has been proposed, and especially with tools like code generators, that works quite well. Obviously, we have all worked with non-JavaScript developers. They're all like, oh, I don't like JavaScript. It doesn't have any types. I don't know what I'm writing. So you don't have that problem anymore with TypeScript. I'm pretty sure they're going to find other reasons not to like JavaScript, but that's another topic. My approach, where I have worked so far with TypeScript and how it actually helped us. We come from backgrounds where there was a gigantic monolithic service, where there was a lot of code like everywhere. Every time you wanted to scale something, it was a nightmare, so breaking that into several microservices helps a lot, especially when it comes to giving a solid foundation where you can use certain services as an example, especially when you have stuff like data layers. It can work in a very sweet way. I'll explain more about how to do that with the interfaces later. TypeScript also is designed to work quite nicely when it comes to separating the concerns. This is a philosophy of when you have code, you break it into several different independent files / functions that each one of them has a single and only use. There are quite a few examples that I'm pretty sure you have all experienced where you have code that is used by several different parts of your system that does multiple things, and when it comes to adding a change to that code, it's a big nightmare to maintain that. So separating the concerns is going to help massively with that. I'm going to show you some examples in the slides coming. It's also quite friendly when it comes to stuff like TDD, because having broken down all of your files, all of your code base into several different files, it helps with testing each file independently without having to rely on big journeys. A good example of that is when it comes to testing React lifecycle methods. I don't know how many people have tried to do that here, testing lifecycle methods. I'm pretty sure that, okay, not many. So in case you do it, you see that it's a big nightmare, and after a point you're like, why do I have to do that? Aren't the integration tests used for that? So that way, if you split the logic outside of the React file, then you can instantly test it. It's way simpler without you having to rely on like some real heavy usage of testing within React. Then we introduced a design system. In the monolith that I was talking about earlier, we had everything in one place, where, especially when it comes to the front end, having a centralized system that includes tokens for colors, for spaces, for stuff like that helped massively. There were times where I have worked in applications where I want to make a button blue, and I just searched which blue is the one that is used in the application, and I found that there were 10 different shades of it. So based on what I found first, that's the one I used. So tokenizing that kind of variables helps a lot, especially with TypeScript. You can have autocomplete so that you can see what this variable is about, its actual value. So it's a quite sweet scenario to use it for. Taking that to the next level, we can have reusable components. We can have stuff like login pages, like forgot password pages, or generally big sets of components that you can reuse them in several parts of your business or your system so that you don't have to actually rewrite them. Shareable interface, again, big fan of interfaces. I'm going to talk a lot about interfaces in the next slide, so I'm not going to bother you yet. Before we start actually talking about interfaces, let's talk a bit about separating the concerns. This is an example for, let's say that we have a folder that is a new recipe. By the way, this is an edge case, but just to give you an idea about how separating the concerns can actually help you. The idea is that this is a folder that is reusable. You can use anything that you want out of it. Everything gets exported from the index file, which is basically the core of this folder. And then you can have stuff like, you can have the new recipe TSX, which is the React file. Then you can have stuff like utils, which are the lifecycle methods that has the business logic, like we talked about it earlier. You can have stuff like validation. And obviously, for each one of these, you can have tests that actually make it much easier to know that you're delivering good quality code. Also increases the code coverage, which is a new thing that everyone is asking for, high coverage. It helps massively with that. And last but not least, the models. So models is where we store the interfaces. So now let's finally talk about interfaces. The way I think about interface is like when you travel and you go to a new place where you have never been before. Interface is like a map. It tells you about what this place is about, so that when you actually walk around, you kind of understand what it is. Example, we have here an interface that is recipe that consists of two types. One is the name of the recipe, which is the type of string, and the other one is the photo of the recipe, which is also type of string. So here we can create a new variable that is called guacamole. It's type of recipe, and we give it a name guacamole, and then photo, we add a URL that shows us a very beautiful picture of guacamole. Going a bit further into interfaces. The first is a typical example of partially using TypeScript. To be very honest with you, the first approach, I believe it's better if you don't attempt any typing at all. The proper way of doing that is, as we see, the second example, like sides, which is an empty function that returns an array of recipes. As we saw earlier in the previous slide, the recipe is of a type name and photo that it includes. So basically, we return the guacamole as we saw earlier, and then we have a new recipe that's called tzatziki, and we return that in an array, and the code editor is quite happy. The very big value that I see with TypeScript when it comes to that kind of stuff is that when you write types that are incorrect, like in the last example, we expect an array of recipes, but we return just one type of recipe. So as you can see, that variable is showing that it has an error. So that can help you save some time instead of running the application and then in the browser or wherever you're running that, you see like going a bit deeper into interfaces. This is a very good example for people that have worked with NoSQL databases where you have gigantic objects. An example here is a recipe where we extended. We add an ingredients variable. We add ingredients, which, as you can see, it's of type. It has a number. I call it now for just like to be easier to understand what it's about. Then unit, which is a string, name, which is also a string, and we expect an array of these ingredients. Then we add the instructions, which are type of string in an array. Then we have the type. This is an interesting case because we can achieve the same result by also using enums. Just for the sake of simplicity, I use that approach. And also, I'm not the biggest fan of enums because they are quite complicated, and also you need to import in order to use them. So that gives exactly the same results as using enums. Then we have difficulty. If you see it has a question mark at the end, that means that it is optional, which means that if you don't include it, the compiler will not complain. Here is an example. So this recipe, tzatziki, which we have added everything as we mentioned earlier. And something that I really like about it is that if you see at the end the ingredients, it has autocomplete where it tells you what kind of values you have to add inside ingredients. Something that has really helped me with using that approach is that when it comes to really nested objects, where sometimes you forget to add a specific variable or you have a typo in one of them and then you may end up spending 20 minutes trying to understand why it doesn't work. With TypeScript, the code editor will automatically complain that doesn't meet the exact schema that you defined earlier. So yes, autocomplete once again saved the day with TypeScript. Sweet approach when it comes to working in several microservices is that you can extend from interfaces. What does that mean? We can create here a new interface that is called special recipe, which extends from the recipe that we showed that we saw earlier. It only has one variable, which is called special, and it's a Boolean. As we can see here, we have a new special guacamole. We call it awesome guacamole. not so special, it doesn't even have a photo. And as you can see, we go through all of the stuff and all of the variables and the values that we added. At the end, we see that we have added a special, which is true, which is something that didn't exist earlier with the recipe type, but it exists in special recipe. So that way, if you want to extend from APIs or from data layers where you want to take the core business of what this code is about, you can extend from it and add further stuff into it. Apart from extending, we can do several other things. Personal favorite is the pick, where you can pick certain parts of the interface that you want. Good example is if we want to make a guacamole preview, which is type recipe preview, which we defined above, we just give it three values. One for name, one for photo, and one for type. Then at the same time, if we have an existing interface and we just want to remove something so that we don't have to redefine everything from scratch, we can use the omit util that basically we say that from recipe preview, remove photo. So we have the guacamole text, which has the name and the type. That way, when it comes to API calls, for example, if you have APIs that give lists of certain data where you expect them to not return like everything, that's a very good approach of doing that, importing the core interface where each entry is about and you can omit the data that you don't want to show, and that way you automatically have your code that is typed without redefining everything from scratch.
Can you make one of them optional?
That's a good question. To be honest, I've never had to do that.
Yeah, exactly. I was thinking the same. I think I read there is a way on Stack Overflow, but I don't remember.
You know, in general, there are way more utils. These are the ones that I have personally used the most. So, yes, and yeah, let's go to the next one now. Generics. Here is where things get interesting. Generics is when you want to add an extra level of abstraction. We have here a class which is a quick recipe. The constructor expects this to have a name and a photo. And then we also have a class which is called menu. It expects one when we initiate it, and then we call the new item function of it. It expects a quick recipe type that we defined above. So if you can see here in the code, we create a new quick guacamole, which is new quick recipe type that we define above. Then we create a new menu, and after that, we just add a new item in the menu, which is the quick guacamole that we defined earlier. So that approach can have a problem. If you want to, let's say, create another menu, which is going to be for drinks, what you would normally do is you would literally create a new class, which is drinks menu, and then tell it that each item is going to be drink type and do the same thing over again. However, what we can do here with generics is that, as you can see here, the menu has a T type, which is type agnostic, and every time you want to add a new item, it depends on what kind of type this item is. So basically, you can add whatever you want. So we have created here a new class which is about beverages. So exactly the same code for the quick guacamole. We add in the menu. Then we create a new lemonade, which is type beverage, which is a new instance of a beverage. And after that, we create a new drink menu, which is exactly the same thing as we did here. We just call it drink menu instead of menu, and then we call exactly the same thing as we did before, the new item, and we can add the lemonade, which is different type than the quick recipe. So that way you can abstract that in a level that you basically don't have to fall into the loop of typing every single thing that you do. So yeah, I've talked a lot about how to use TypeScript. However, I need to show you some examples, so enough is enough with me talking about how TypeScript works. So, some React specifics examples. We have here a home page which uses a menu wrapper. And inside the menu wrapper, we just want to display some recipes. As we see, the menu wrapper expects two props. One is name and the other one is children. We just put the name inside header 1, and then whatever the children are, we just render them. As you can see, underneath, we have the recipes, which, from what we see, is an array. We map, and each item is a different recipe, and then we return the recipes as we wanted. This is the actual interface in order to do that. Based on what we've talked about, when you see that, do you think that this code is going to work or not? Okay, so here we say that the children need to be of type React element. So, no, it's not going to work. Because as you can see here, we have an array and we map through that. So, yeah, exactly. In order for it to actually work, we need to say that the children are an array of React elements. That approach can be quite sweet. So if we do that, then we see that the code editor doesn't complain anymore. So that way can be quite sweet when it comes to, especially when you have forms that you expect them to have very specific kind of children that go into, especially if you follow like a form steps where you need like wizard UIs and each form has like a very specific structure. That approach can help a lot control what exactly goes in there so that you don't just go wild without like caring about what is happening. So now let's talk a bit about what happens when we want to have compatibility with libraries that are not with TypeScript. So there is something called definitely type, which is a repository that has type definitions for most of the libraries that you're going to use. If you check them on GitHub, they have like 6,000 libraries they support. First thing is that when you install one library that doesn't have TypeScript support, your code editor will complain and will tell you that you basically need to run something like that, where you need to yarn add the add types, and then for this example is React library and add it as a developer dependency. That works quite okay. However, what if we have packages that don't have any support indefinitely type? What do we do in that case? This is where we have the typing declaration files. Typing declaration file, for example, we have this new cookbook, this library called my cookbook, where we export out of it the recipe lookup, and then from what we remember, it expects the name of the recipe and then another parameter with another argument that we don't remember exactly what it is. So in plain React, if we do that, it's not going to complain. So we can create a file that is called typings.d for declaration.ts, and inside that file, or we can name it whatever we want as long as it ends with .d.ts. This is where we can declare a new module, which is for my cookbook, and we say that this module exports a function that is called recipe lookup, which expects two arguments. One is name string, and the other one is type, which is type that we talked about earlier. As you can see, as soon as we do that, the code editor will instantly start complaining. It will tell us that it's not the type that we expected. So then we have a brief idea about what we can do. So that way, no matter if there is a library that supports TypeScript or not, we can use it, and basically using that approach, we can only type the parts of the the library that we actually care about. So let's do a summary of what we've learned today. Very important to mention that not every single thing needs to be typed, because if you type everything, first of all, there are certain parts, especially in the front end, that you're just like, in my opinion, you're wasting your time typing because it doesn't make any big difference. Stuff like the critical parts of the code, like user bases, like Redux stores, like APIs, validations, data layers. These are the parts that need to be typed, and especially they're going to help you with not having that many bugs. So yes, interfaces. Yeah, I showed you how much I love interfaces. I use them everywhere, especially when working with several other APIs coming from different packages. I just import from these packages the interfaces, and we can do stuff like extend or omit them and make use out of the stuff that we want from these interfaces, and separating the concerns. We talked about how splitting the code is going to make our quality much better, how we can have more control over the code that we use, how we can add more tests. It's a big, big philosophy, if you have seen these days. Then the typing definition files, in case you are working with a library that doesn't have any TypeScript support, you can literally just go and create your own TypeScript support for this library. And something that is good to mention about typing definition files. I've seen quite a few libraries that when you go to their documentation, you see in the README file that they have a link to their own typing definition file. So you can literally just copy it from there, put in your code, and then it works quite well. Yes, also you saw some new memes in case you haven't seen them before. Yes, that's it. So any questions?